All right, today we're going to be starting with day 6 of 6 and 7 with solving exponential and log equations. I have these lined up just to review the inverse property of log and exponential functions. So when we look at our row of 2 to the x, 3 to the x, 4 to the x, that's exponential. The inverse operation or inverse function of exponential is log. So what we can do is take the log base 2 of 2 to the x, and what does that equal? It equals x. Log base 3 of 3 to the x equals x. Log base 4 of 4 to the x equals x. We learned that property earlier on in the unit, and that's your inverse property of log and exponential. We could keep going. ln of e to the x is x. Log base 10 of 10 to the x is x. So we're going to use that property to help us solve exponential functions. Now it works also if you're starting with a log function. If I take this and raise it to my exponent, so 2 raised to the log base 2 of x is x. 3 raised to the log base 3 of x is x. E raised to the ln of x is x. And it goes on forever and ever. And these are the properties that we learned earlier on in the unit. B raised to the log base b of x equals x, and log base b of b to the x equals x. So we need to make sure we know those because that's going to help us with solving. So let's go ahead and look at question 1. In question 1, we are going to solve for x. 3 times 2 to the x equals 1/6. Now notice that it's an exponential equation, so we're going to use logs to help us solve for our exponent. But before you do that, you do need to use inverse operations to get 2 to the x by itself. So you can either think of that as division by 3 or multiplication of 1/3 on both sides. Whatever you do to one side, you got to do to the other. And you get 2 to the x equals 1/18. Now this is where we're going to introduce logs and use the property of inverse operations. So if I have 2 to the x, if I write this as log base 2 to the x power, that just equals x. But if I do that on one side, I have to do it to the other. Because we have an equation, we have to keep it balanced. And so I do log base 2 of 1/18. Now if I'm looking for an exact answer, this would be it. Okay, that is the exact answer. Or what we can do is plug this into our calculator to get a rounded answer, and it'll give you negative 4.170. Now you might be thinking, how do I plug that in? So I want you to take a look on Desmos. If you go into function, you can actually change your base to a base 2. If you're on a graphing calculator, you're going to hit the math button, then the alpha button, and then the math button again, and that's how you change the base to base 2. So that's how we solve an exponential. You get the exponential with the base by itself, so 2 to the x, 3 to the x, 4 to the x, e to the x, and to undo an exponential function, you introduce logs to both sides. The base must match, okay? All right, so in number 2, we have another exponential function. Again, the goal here is you need to get this 3 to the x plus 1 alone. So I'm going to undo the division by 1/2 by multiplying both sides by 2/1. And that leaves me with 5 plus 3 to the x plus 1 equals 100. Then I'm going to do the inverse operation of addition and subtract 5. And now I have this exponential by itself, and that was our goal. So to get rid of a base of 3, we want to introduce a log to both sides, and the log needs to match in order to use the property. Log base 3 of 3 to the x plus 1, that will cancel out and just be x plus 1. If I do it to one side, I have to do it to the other. So that's going to leave me with log base 3 of 95. And then I'll do inverse operations and subtract 1. Now you do have to be careful that that minus 1 does not get attached with the log. So this right here, again, would be an exact answer. But we have our Desmos, we can plug this in, and when we type it in, it'll spit out 3.145. And remember, you can always take that and plug it right back in here for x and see that it actually does equal 50. Okay, so this next one is a log equation. So to get rid of logs, we're going to introduce exponential functions. But before we do that, we do have to have it just as one log. So we're first going to condense here using the product property. So that means we multiply 6 times x plus 4, which gives us log base 2 of 6x plus 24 equals 3. Now, if you go back and look at your inverse properties of logs and exponential functions, to undo a log, we turn the log portion into our exponent. So this is called exponentiating both sides. We make that an exponent, okay? So now we have 2 raised to the log base 2 of 6x plus 24. If I do that to one side, I have to do that to the other. So on the left-hand side, our log base 2 goes away, and we're left with 6x plus 24 because of our inverse property. And then we get 2 cubed, which is 8. And now we have a nice simple equation. 6x plus 24 equals 8. Go ahead and subtract 24 from both sides, and you end up getting negative 16. We divide both sides by 6, and that leaves me with negative 8/3. The one thing when you are solving for logs, you have to remember to plug it back in and check it, because if you plug that back in, negative 8/3 plus 4 is not negative, it is positive. But you always have to make sure that when you plug it back in, you're not taking the log of a negative number. Negative 8/3 plus 4 is positive. And if you plug this in and add it to log base 2 of 6, it does end up equaling 3. So you do need to check your solutions when solving logs. So just make sure you check for extraneous solutions. And those are solutions that show up, but they don't actually work. Okay, this next one is ln of 10x minus ln of 5 equal to 1. So again, we do the same thing. We start by condensing. We get 10x over 5 using the quotient rule equals 1. And inside that simplifies down to 2x. And now to undo the log, we want to introduce with a common base. And since natural log is base e, we're going to exponentiate that. So it becomes e raised to the ln of 2x, and this becomes e to the first power. So on the left side, you get 2x. On the right side, you get e to the first. And when we solve this by doing inverse operation, we divide both sides by 2, and our answer is e over 2. And that does have a value, okay? You can get a rounded answer if you plug it into your calculator. You can just do e over 2, and you can round it. But again, make sure you always check that it does work. And I checked it here on my calculator. So make sure you practice checking that. Okay, this next one, I have a log base 3 equals a log base 3. And this is good because they are the same base. So to undo a log function, we introduce exponential. So since it's log base 3, we're going to do 3 raised to log base 3 of 5x minus 1 equals 3 raised to log base 3 of x plus 7. Again, this is a property. That gives us 5x minus 1 equals x plus 7. And then now we have a simple algebra 1 problem. So we get 4x equals 8 and x equals 2. And again, you always want to check that it works. All right, this is our final one. We have e to the 2x minus 3e to the x plus 2 equal to 0. This is an exponential function. It is in quadratic form, and what that means to be in quadratic form is it follows this kind of pattern. The x squared minus 3x plus 2 equal to 0. So we factor this just like we would the quadratic, 2 factors of 2 that add up to negative 3, x minus 2, x minus 1. Instead of being x, it'll be e to the x minus 2 and e to the x minus 1. We factored like this last year in Algebra 2 where it was in quadratic form, but it's truly not a quadratic. And then you set each of these equal to 0 to solve. So it almost becomes 2 separate problems. We get e to the x equals 2, and here we get e to the x equals 1. To undo an exponential function, we introduce logs to both sides. So over here we get x equals ln of 2. That's our first answer. Over here we get x equals ln of 1, which is equal to 0. So you actually get two answers. You do want to plug them back in for both x's, and both do check. Please take some time to do that.